Okay, hi everyone. Give formulas and pictures for the nth roots of unity, whatever that means. I'll explain that in a moment. And do it for n equals 2, and n equals 3, n equals 4, n equals 5, n equals 6. Okay, so these are solutions to this equation. X to the n equals 1. Okay, so for example, the solutions to x to the third equal 1. Well, 1 to the third is 1. And you might try like negative 1 to the third, but that's actually not equal to 1. So that's not a solution, negative 1. So what are the other solutions? Well, we have to go to the complex numbers. Okay, so let's just start with n equals 2. Then we need x squared equals 1. Okay, well that's easy. Minus 1 and 1. That's it. The formula is 1 and minus 1. And the picture is here. And let's see, n equals 3. That means x to the third equals 1. Okay. For this, we actually need to go to the complex numbers. We're going to look at this unit circle. And 1 will be an answer because 1 to the third is, in fact, 1. But then there's going to be this answer and this answer. So if we're at this number right here, and let's call it z, no, okay, I called it x, let's call it x, then x squared is just going to be, well, remember this number here is on the unit circle. This is the unit circle. And so the size of x is 1. The modulus of x is 1. So if x was like x1 plus I x2, then the modulus is defined to be the square root of x1 squared plus x2 squared. This is the size or modulus of a complex number. But anyway, what is this number? Well, it happens to be, okay, so minus a half plus root 3 over 2 times I. And then actually the other one is just the complex conjugate of this. So remember, x bar is the complex conjugate. So if this is x, then this is x bar down here. All we do is we just flip over the real axis. In other words, if we had x1 plus I x2, then x bar would be equal to, and now I can remove the bar, and I get x1 minus I x2. So you see that all I do is just go vertically downward instead of upward. And so that means we just go minus root 3 over 2i, and then 1. So x equals this, x equals this, x equals this. These are the 3 solutions to this equation. Okay. Okay, so yeah, and that makes sense because, well, let's look at this one here. It's sort of roughly here. So if we go once like that, then if we go twice, we'd be all of a sudden here. And if we go one more time, we'd get back to 1, which is where we wanted to go. So that was x times x times x. So each time we rotate by some amount. But I guess for this one, we'd rotate by, well, not 2 pi, that'd be a whole rotation, but we just want that much of a rotation, which is 2/3. 2/3 of 2 pi. 2/3 of 2 pi, which is 4 pi over 3, but it's sort of easier to understand if you think 2/3 of a full rotation, and that's this number right here. Okay, I guess I called it x bar. Yeah, so this is x, and this is x bar, or it's actually also equal to x squared if this is x. Yeah, so then this would be x squared, x to the third. Well, now I'm just messing everything up because it's just confusing things. But anyway, so let's call that done with n equals 3, and let's move on. Let's do n equals 4. The fourth roots of unity. What solves this equation? One, I, minus 1, minus I. Okay, we're done. Those ones were easy. Okay, 1. Because now we're just going to rotate, yeah, a fourth of the way. 1/4 of 2 pi is the rotation associated to I. And the others are like 2/4 and 3/4 of 2 pi would be this length, this rotation, and that's sort of minus I. So anyway, let's do n equals 5. What are the solutions to x to the 5th equals 1? Okay, so, okay, that's a terrible circle. Let's go like, so if I go 1, then 1 times 1 times 1 times 1 times 1 is in fact 1. So that works. So this is a solution. Let's do another one. How about this? So this is going to be the number cosine of 1/5 2 pi plus I times sine of 1/5 2 pi. Okay. I hope you're okay with me writing 1/5 2 pi. What that means is 1/5 times 2 pi, which I guess is another way of saying 2 pi over 5. And so this is the formula for that number right there. Well, now let's check, like if we do this, if we go 1/5 of 2 pi and we multiply it by itself, we're going to go another 1/5 of 2 pi, and we'll be here. Then we'll multiply again by itself, and we'll be another 1/5 of 2 pi, and then another 1/5 of 2 pi, and finally we'll be back to 5/5 of 2 pi. And so that's how we get the right thing. Now, interestingly enough, also we could do minus. So the minus then would give us this number. And let's look at that number right there. So it's going, I mean, one way to think about it is 4/5 of 2 pi. So it's actually the same as 4/5 of 2 pi plus I sine 4/5 of 2 pi. And you can check that that's actually equal to this expression up here, but with a minus sign. Anyway, we don't even really know what how do you know, like, what's cosine of 3? Do you know how to calculate it, to compute it? No, you don't. Okay, so here's what we're going to learn in this course. We're going to learn that cosine is 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial minus dot 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 forever and ever. And what this dot 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 means is we have to take a limit of the partial sums of this infinite series. And so the first partial sum would be 1, the second partial sum would be some other number, the third partial sum we'd add up the first 3 terms, the fourth partial sum would be we'd add up the first 4, and we don't know how to do that yet. So anyway, that's how we would compute these numbers. What else? There should be 5 solutions. I think we got 3 solutions so far. The other ones are here and here. What are those? Well, this one would be cosine of something plus I times sine of something. Why? Because it's on the unit circle, right? So now the question is how far? Well, what's this angle? Well, it's some amount of 2 pi. I would say it is 2/5 of 2 pi. Fifth, so that when we do it 5 times, we'll get 2 pi. And 2/5 of 2 pi. That looks right. And then this one down here is 3/5 of 2 pi. But we can tell by just looking that it's kind of going to be vertically. And so actually you just put a minus and that flips and it'll be complex conjugate. And so those are the 5 solutions. I mean, here's another way to write it. Cosine of k/5 of 2 pi plus I sine of k/5 of 2 pi for k in 0, 1, 2, 3, 4, 5. Or we could take k in 1, 2, 3, 4, 5, 6, because the 6 and the 0 are going to give us the same number. And that is wrong, because we don't need, actually the 5 and the 0 are going to give us the same number. So we don't need that one, because these are fifth roots of unity. There's the denominator, some fifth, and so 5 of them gets us back to 0. So we only need 0, 1, 2, 3, 4, 4. So that's, these are five numbers. And if we wanted to start at 1, then we definitely don't need, then we do need 5, but we don't need 6. So this is now 5 numbers. Good, and so these are the solutions. Solve x to the 5th equals 1. Okay, x equals these. Good. Let's do n equals 6. N equals 6. So x to the 6 equals 1. Well, let's first do the formulas. Cos of k over 6 of 2 pi plus I times sine of k over 6 of 2 pi. For now, we actually need one more. Oh, let's take 1, 2, 3, 4, 5, 6. We need 6 roots of unity. What do they look like? Well, here are the third roots of unity. Remember this for n equals 3? They're up there. Here was the cosine of some number, and here was the sine of some number. And anyway, these were the third roots of unity. But now we just chop it even further. So we go this way, and well, I don't know where it's supposed to be. I guess there, and then here, and then here. And so that's the picture. Now, what you'll notice is that they always form a regular polygon. So that's a hexagon. And this is a pentagon. And this is a quadragon, also called a square. And this is a triagon, called a triangle. And this is a, well, something. Anyway, that should about do it for this one. Yeah. These come up a lot, so it's worth just seeing the nice geometry. The idea is that when you multiply a complex number, when you multiply two complex numbers together, what happens is you rotate some amount. Or when you multiply by some complex number, like let's say this one. Here it is. Here's the complex number. When you multiply by x, you are going to rotate by this angle, And you're going to stretch by this length called the length of x, which is actually a real number, whereas x is a complex number. And this is an angle, which is also a real number. And sort of like polar coordinates. And so if you think in polar coordinates, these formulas make a lot more sense. Like here we have 90-degree rotations, or else we have 180-degree, or we have negative 90-degree, which is another way of saying 270-degree. Or in radians, it's much easier. It's just how much of 2 pi, maybe 1/4, maybe 2/4, maybe 3/4, and those are these numbers here. Notice that cosine of 3/4 of 2 pi is, in fact, 0. And plus I sine of 3/4 of 2 pi. We are supposed to get this number, so that is, in fact, -1. And we get minus I. I'm supposed to circle them, maybe. Okay, that's all done. Can you do this yourself? What are the nth roots of unity? What are the formulas for them?